Hello, how's everybody doing? How do you like my background? Isn't it awesome? Talking to my students. Did anybody have any questions for us to get started with today? All right. If you guys don't have any questions, then we're going to go ahead and get started with section 10.1. 10.1 is all about making graphs. It's not the type of graphs that you're thinking of maybe from algebra class where you had an X and a Y, but it's the sort of graphs that you're going to be making if you collect some data and want to display your data. So there might be some bar graphs, some histograms, some pie charts, and that sort of thing. I'm going to start with problem number 4. It says a class of 30 students made the following scores on a 100-point test. I'm not going to read them all out to you, but you might notice we've got a 58, we've got a 98, we've got lots of scores all over the place in between those values. And the first thing we're going to do is arrange the scores in increasing order. So I've gone ahead and done that. So here's our scores again. And then the next question is, what's the lowest score and what's the highest score? That's a lot easier to see once you've done the work of arranging them in increasing order. We can see that the 58 is the lowest score and the 98 is the highest score. And then the next question is, what score appears the most often? Okay, so we might at first think maybe it's 72 because there's 3 of those, but then I might notice that there's 4 76s. So I think maybe it's 76, and in fact it is 76. That's the score that appears the most often. Next, we're going to make a line plot to represent the data. A line plot can also be called a dot plot. So remember that our lowest one was 58, our highest was 98, and there were 3 72s and 4 76s. Okay, so when we make this, we're going to put 4 dots above the score of 76, and then the 3 dots are going to be above the score of 74. There was only 1 score of 58, there was only 1 score of 98. So the number of dots shows us how many times that particular value showed up in the data set. Okay? And sometimes we'll make this, but instead of using dots, we'll put X's, and that's okay. Next, we're going to make a frequency table where we group the data in increments of 10. So we could go from 50 to 59, from 60 to 69, and so on. There's only 1 score in the 50s. There are 4 scores in the 60s, 12 scores in the 70s, 8 scores in the 80s, and 5 scores in the 90s. Next, it says from the information in the frequency table, make a histogram. Right, here's a histogram. When you make a histogram, the bars do touch. When you make a bar graph, the bars don't touch. When you make a histogram, that's because your input values are numerical values where you could change how you're grouping your numbers together. Then it asks which interval has the most scores. So for that, we're looking at the highest bar. And we can see that's the interval from 70 to 79. Okay. For problem number 5, it says to make a stem and leaf plot for the following weights of children in kilograms. Use 2-digit stems. So our stems will go on the left. So we'll have a stem for weights in the 17s, and then for 18s and for 19s, we're going to use stems anywhere from 15 to 22 because that's what the data is. Okay, so here's our setup. And now notice that our first data value is 17.0. So we're going to be putting a 0 next to the 17. The next data value is 18.1, so we'll put a 1 next to the 18. And then the next one is 19.2, so we'll put a 2 next to the 19. Okay, so here's the 0 next to the 17, and the 1 next to the 18, and the 2 next to the 19. And then the next one I see is 20.2, so next to the 20, I'll put a 2. And the next one is 21.1. So next to the 21, I'll put a 1. And then I see 15.8. So next to 15, I'll put an 8. Then next to 22, I'll put 0 for 22.0. And then next to the 16, I'll put a 1. Okay. And then next to the 15, I will put a 9 because my next number is 15.9. So after I've done all my numbers, I end up with this. And I'm almost done. The only thing I want to do is make sure that all my leaves are in increasing order. So 8, 9, that's an increasing order. 1, 3, 4, that is. Okay. The only one that actually isn't is the one next to the 20. I want to move my 6 so that it's in between the 3 and the 9. Okay. So usually when you do this, your leaves won't really be in increasing order. So it is always a good idea to come back at the end and put them in increasing order. Any questions so far? Number 6, this time we are given the stem and leaf plot. And it says the stems are the tens digit. So this 2, we're going to have a 2 in the 10 spot. So this 0 makes the number 20 and 20 and 21 and 21 and 27 and so forth. And then down here, we're going to have 54 and 57. So next, it says to make a line plot for the data. So remember, we did that before, and we would put just a dot above a number. So every time we saw that number in the data set, it would put a dot there. So I will have 3 dots, although they don't have to be dots, they can be X's, 3 above the number 35 and 3 above the number 43. So remember again, the stems are the tens digit. On the previous problem, the stems were the tens and the ones. So we had the leaves over here for the tenths place. So the first thing to do is to make your number line. I didn't have quite enough room to count by ones, so I counted by twos. And then I used X's. So I have 2 X's for the number 20, and then 2 X's for the number 21, and then just 1 X because I only have 1 27. And then I have a 31 and a 33. Oh, sorry, here's 27, here's 31, here's 33, and then I have 3 35s. Any questions so far? Okay, so we started with our stem and leaf plot, and then we made a line plot. All right, here's the stem and leaf plot again. Next we're going to be making a histogram. And we'll be grouping the data by tens. So we'll have 20 to 29, 30 to 39, 40 to 49, and 50 to 59. Okay, those are the bins or the classes. And here's the histogram. So remember again, when you make a histogram, the bars touch, and that happens when the input variable is numerical and you have bins that you could change. So for example, I could have made bins that went from 15 to 24 and then from 25 to 34. I could have grouped things differently. And that's when you make a histogram and your bars touch. Next, we're going to take a look at number 7. It says make a back-to-back stem and leaf plot for the following test scores. So we have 2 different classes. Here's the test scores for class 1, and they're not in ascending order. And here's the class scores for, or the scores for class 2. And again, the scores are not in order. All right, to make a back-to-back stem and leaf plot, you put the stems in the middle, and then the leaves will have leaves over here for class 1 and leaves over here for class 2. And we could have done it the other way around. We could have put class 1 on the left and class 2 on the right. There's no one correct way to do it. And now because I have 57, I will put a 7 over here for class 1. And then because we have 62, I'll put a 2 over here. And because class 2 had a 68, I'll put an 8 over here next to the 6. So I have a 57, so I put my 7 as my leaf. And then I have a 62 for class 1 and a 68 for class 2. And then next I have a 76 for class 1 and a 79 for class 2. So I'll put a 6 as a leaf for class 1 and a 9 as a leaf for class 2. And then next I have an 80 for class 1. So I went ahead and put my 80. And then I have a 93 for class 1. So I put my 3, okay? And then I just want to go ahead and do all my numbers. So once I've done all my numbers, it'll look like this, okay? And then the next thing to do is to put them in order. So 7, 9, 8, that's not in order. I like it to go 7, 8, 9. And then 2, 0, that's not in order. I want it to go 0, 2. All right, so 7, 8, 9, and then 0, 2. And it makes things easier if for class 2, you put the low numbers next to the stem, okay? So even though it looks a little weird to go in descending order, 8, 7, 6, that's just so that the low numbers are all next to the stems. Okay, so we've put the 7s in order and the 8s and then the 9s. Any questions about anything so far? Next, it says which class seems to have performed better. So here's the back-to-back stem and leaf plot that we made. So I noticed that class 2 has many more scores in the 90s than class 1. So class 1 only had 3 scores in the 90s, and class 2 had double that. It had 6 scores. And the scores that class 2 has in the 70s are bigger than the scores that class 1 has in the 70s. Right? Class 2 doesn't have any scores in the 50s, while class 1 does. Right? So I would say that class 2 performed better. Does that make sense? Next, we have some bar graphs to represent the average monthly precipitation in Portland, Oregon, and in New York City. So the first question asks, which city receives more precipitation on the average in January. So I noticed that Portland in January gets almost 6 inches, whereas New York City gets about 2.5 maybe. So I would say Portland gets more in January. Next, in how many months are there less than 2 inches of precipitation in Portland and in New York City? So basically, we're thinking about making a horizontal line at 2 inches and seeing how many months are below that. And I think for Portland, there's 4 months. So in June, July, August, and September, Portland gets less than 2 inches. And New York City never gets less than 2 inches. Next it asks, in which month does the greatest amount of precipitation occur in Portland and in which is the least? So I would say that the bar for December is the highest, so they get the most precipitation in December, and the bar for July is the smallest, so that's the month where they get the least amount of precipitation. And then part D is asking us the same question for New York City. And it looks to me like the bar for August is the highest, so that's the month where they get the most, and the bar for January is the lowest, so that's the month where they get the least. Which city has the greatest annual precipitation? For this one, I had to try to estimate as best I could how tall the bar was for each month. So for Portland, I came up with about 37 inches when I tried to guess how tall each bar was and then add them all up. And then for New York City, I came up with almost 41 inches. So I said that New York City got more. Any questions so far? Okay, next we're going to take a look at number 9. It says, given are several gasoline vehicles and their fuel consumption averages. All right, so we've got the Buick that gets 27 miles per gallon all the way down to the Land Rover that only gets 16 miles per gallon. And then part A says to draw a bar graph to represent the data. So we're going to be making a graph that looks something like this, and we're going to have a bar, a horizontal bar for each type of car, and the length of that bar should correspond to the mileage. So for the Buick, I'd want a bar that comes out to 27. Okay? And that looks like this. That's my bar graph. And then part B asks which model gets the least miles per gallon and which one gets the most. And that's pretty easy to see that the Land Rover gets the least miles per gallon and the Geo gets the most miles per gallon. And I don't know when they came up with this question because I don't think they make Geos anymore, but that's okay. Part C says blank gets about 3 times as many miles per gallon as blank. And I said that the Geo that got 46 miles per gallon got about 3 times as many miles per gallon as the Land Rover, which gets 16. Because I know 15 times 3 is 45, so that's about 3 times as many. Next, we're asked, what is the cost of fuel for 80,000 miles of driving at $2.79 per gallon for each car? So this is a good question. It brings in the dimensional analysis that we did back in the last unit. So for the Buick, I want it to travel 80,000 miles. I know that 1 gallon of gas lets it go for about 27 miles. So the miles will cancel. And then we can multiply by $2.79 per gallon, and the gallons will cancel. And so we find that that costs almost $8,300. Okay? And next I did the BMW, and I just did the same setup, but changed the 27 to 28. And now it's less than $8,000. For the Honda Civic, now I got to change the number on the bottom to 35 miles. And now it's about $6,400 approximately. And then the Geo that was getting 46 miles to the gallon. So now it's less than $5,000. And then I did the Neon, which was getting 38 miles per gallon. It's about $1,900. And then there is the Land Rover with the whopping 16 miles per gallon. Oops, that should say 16. I don't think I changed it. But it was about almost $14,000. Okay, and then they asked, instead of using a bar graph, could we use a histogram? Just having a slight cat issue here. Okay, could we use a histogram instead? I don't think we could use a histogram because the input variable here is the type of the car. And that is not a numerical quantity that can be broken up into different intervals. So a histogram can be used when the input variable is something like the age or the height. Any questions about anything so far? Okay. Next, we're going to take a look at number 10. It says the population of the world's 9 largest urban areas in 1990 and their populations in 2010 are given in the following table. Okay. So we've got all these different cities, and we've got 2 different numbers for their population. And we're going to make a double bar graph of the data where we'll have 2 bars for each city. So it's going to look something like this. And one bar will be for the population in 1990, and the other bar will be for the other population value. I didn't have enough room to write out all the names, so I abbreviated. And when I did that, I came up with a graph that looks like this. So we can kind of compare the 2 values. Which urban area has the largest percentage growth? To find the percent growth for Tokyo, first we figure out how much the growth value is. So we subtract the later value minus the earlier value to get the total amount of growth. And that was 5.2 million. And then next, we figure out what percent of the original population that number is. Right? We can set up a proportion. We put the 5.2 million on top and the earlier population value on the bottom. And when we solve, we'll get 19. So that tells me that Tokyo had an approximate 19% growth. Okay, I went ahead and did that for all the different cities. Okay, here was Tokyo that we did on the previous slide. Notice that Mexico City actually ended up with fewer people. So I'm going to call that a negative growth. And so that's a negative percent growth. Okay, and Rio de Janeiro also had a negative growth. The rest of them were positive though. Part B asks, which urban area has the largest percent growth? That's going to be Bombay. It has the 59% growth. And then it asks which area had the smallest percent growth. That's going to be Rio de Janeiro because it had the biggest decrease in population. Any questions about anything so far? No? Number 11 says public education expenditures in the United States as a percentage of gross national product are given in the following table. So we've got the expenditure for various years. First, we're going to make a line graph illustrating the data. So we're going to put the years on the x-axis and the percents on the y-axis, and we're basically going to put a dot for each line on the table, and then we're going to connect the dots. So we get a graph that looks something like this. Part B says to make another line graph illustrating the data, but with a vertical scale unit interval twice as long as that of part A, but otherwise it's exactly the same. So for example, if from 0 to 8 on this graph is, for example, 2 inches, on my other graph, I just want to double that and make it 4 inches. Right? And if I do that, it looks something like this. Which of the graphs would be used to lobby for more funds for education? Right? Which of these graphs would make somebody think that education isn't being funded enough? I would say the first graph, because the first graph makes it look like things really haven't changed very much for 50 years. Whereas the second graph, okay, even though it's the same numbers, because this graph is going up a bigger distance, it kind of gives you the impression that things have changed more. So which graph would be used to oppose budget increases? That would be the second graph, because it appears to show a bigger change. Again, even though these are the same exact numbers. Number 12, the circle graphs here represent the revenue and expenditures. You'll see the expenditures on the next slide of a state government. Use them to answer the following questions. What is the largest source of revenue? You're just looking for the biggest spot on the pie graph, and that would be taxes. Part B, what percent of revenue comes from federal sources? And that's the blue part of the pie graph. That's 20.3%. Part C, find the central angle of the pinkish section, charges for goods and services. We're trying to figure out how big this angle is right here. We know that the category corresponds to 17.8%. So we need to figure out 17.8% of 360 degrees. We know that all the angles together would add up to 360. So we can set up a proportion. We can do 17.8 over 100 equals x over 360. And if we solve for x, we get just a little bit over 64 degrees. Right? When you use your protractor, you won't be able to measure 64.08. You would just make a 64-degree angle. Here's the graph for expenditures. It says what category of expenditure is smallest. That's going to be this darker blue section, which is letter B. That's natural resources. Which 4 categories, when combined, have the same expenditures as education? So we want to try to come up with 4 categories where when we add up the percents, it comes out to be 41.6. And if you add the social resources value, well, social assistance, 19.2, plus transportation, 15.2, plus the health and rehabilitation, that's 4.9, plus the natural resources, the 2.3, that comes out to be 41.6. Next, we want to find the central angles for these 2 categories. The first category is business, community, and consumer affairs, and the second category is general government. So for business, community, and consumer affairs, the category corresponds to 6.5%. That means we need to find 6.5% of 360. And we can set up a proportion again. We do 6.5 over 100 equals x over 360. and that will give us 23.4. And then for general government, that category corresponds to 7.1. So we can do the proportion. We'll do 7.1 over 100 equals x over 360. And when we solve for x, we get 25.56 degrees. Did anybody have any questions on anything? Okay. Next, we'll look at number 13. It says the following circle graph shows how a state spends its revenue of $4,500,000,000. We want to figure out how much was spent on each category. So I started with the grants to local governments, that's 28.2%. And I set up a proportion, 28.2 over 100 equals x over 4,500,000,000. And I solved for x, I cross multiplied, and I got 1,269,000,000. And then I did salaries and fringe benefits. That was 25.8%. Okay, that's a little bit smaller than the last category, so I should get a slightly smaller number. And I set up my proportion again. This time I did 25.8 over 100. And this time when I solved, I got 1,161,000,000. So it is a little bit smaller. Next, I went to the grants to individuals and organizations. I set up my proportion with 19.4 over 100. And this time I get 873 million. And then next I did the operating, and that was 13.8%. So I did 13.8 over 100. And I came up with 621 million. And then other was 12.8%. And I set up my proportion, and I should get a number that's a little bit smaller than 621 million. And I got 576 million. Any questions? Okay. We'll take a look at number 14. It says the following pictograph represents the mining production in a given state. We notice that each car represents $10 million. So part A says about how many dollars worth of bauxite was mined. So I have one car that's 10 million, and then about another half a car. So that's another 5 million. So I've got 1.5 cars, which is 15 million. This car is 10 million, this is 5 million. And then for sand and gravel, it's only half a car. So that's about 5 million. And then for petroleum and natural gas, I needed to add up, figure out how many cars there are. And it came out to be 8.5 cars. So that's 85 million. Remember, each car is 10 million. Is that okay? Okay, and then number 15, it says the following are data on public school enrollments. So in 1910, there was almost 18 million students. In 1920, there was about 21.5 million, all the way to 2000, where there's 47 million or so. And part A says, choose an appropriate icon, a reasonable amount for it to represent, and draw a pictograph. Well, since we're recording how many students there are, we can use a stick figure. And since we want to show values between 17 million and 47 million, we could have each person represent 5 million. And so then this picture roughly shows the amounts for each year. And then it asks, in which decades were there increases in enrollment? So from 1910 to 1920, there's an increase. So I'm going to say that in the 1910s, there's an increase. Okay? So there's an increase in the 1910s. And then from 1920 to 1930, so over the decade, the 1920s. And then there's an increase when we go from 1950 to 1960, so in the 1950s. And then there's an increase from 1960 to 1970, so in the 1960s. And then there's another increase from 1990 to 2000. So, sorry, I should say in the 1990s. That one should say in the 1990s. What other type of graph could represent the data? What else could we use besides a pictograph? We could have used, I would say, a bar graph or a histogram. Right? So we could have made bars to show these amounts. And we'll try to look at number 16 real quick unless there's questions. Okay, number 16 says the college admissions office uses high school GPA as one of the selection criteria for admitting new students. At the end of the year, 10 students are selected at random from the freshman class, and a comparison is made between their high school GPAs and their GPAs at the end of their freshman year in college. So we've got these numbers. First, we're going to make a scatter plot of the data. So this might be kind of what you think of when you think about making a graph. So we could use the high school GPA as the X and their freshman GPA as the Y. So we're just going to basically be plotting a bunch of points. So it'll look something like this, right? So here, if we graph, we would get a bunch of dots like this. And then next, we're going to draw a regression line. So that's going to be just a best fit line that approximately captures the trend of the data. So it's going to look like this, basically. And we can see that these two quantities are positively correlated. And what that means is the higher their high school GPA, the higher their freshman GPA. Okay. Any questions so far? Okay. Let's go ahead and take a look at the next one. It says, students taking a speed reading course produce the following gains in their reading speeds. Okay, and we have one variable that tells us how long each student's been in the program, and the other variable tells us their speed gain in words per minute. So the first thing we're going to do is make a scatter plot. So our X's are going to be how many weeks they're in the program, and then the Y will be their speed gain. And it looks like this. And then next, we'll sketch the regression line. And it looks kind of like this. Okay, so it's just a best fit line that fits the data. And we can see that these two variables are positively correlated. So in general, the more weeks that a student is in the program, the larger their speed gain. I think this is a good stopping point. Did anybody have any questions about anything? Okay, well, thank you for coming today. Remember, you have some problems, some homework sets to do on MyLab, and you also have a quiz on MyLab. And I'll see everybody tomorrow.
Thank you.
Thank you.
Thank you.
Bye. See you tomorrow.
Bye.